Hello, everyone, and welcome to another workshop in the Polaris Hackathon series. Today, we have a special workshop on smart contract programming with Python. With us is Tyler Adams from COZ. Tyler, please tell us a little bit about yourself and your work.
Sure. So I'm Tyler, and I work with the COZ organization and the Neo ecosystem. I've been a developer on Neo since before it was called Neo, since AntShares days. And I done a bunch of different stuff in the ecosystem, starting with some of the first contract development that was really done at all on the platform. So I helped with like the NEP5 standard in Neo Legacy, for example. Lately, I guess my focus is really on just keeping the ecosystem running, whether that's facilitating different experiences like this, or bringing up backends for people, providing technical support. I'm kind of all over the place. I guess that's my personal intro.
All right, great, and thank you for that information. So, are you ready to start your presentation?
Sure. Let's see how fast or far we get through it. I think we'll be all right.
Fingers crossed.
Yeah, so this is going to be a very high-level overview of smart contract development in a Python environment. Generally, I run this tutorial on a Windows environment. Today, we're going to use OS X. So that will be interesting. I'm not actually sure what is installed on here. I'm pretty sure Neoexpress is on here. I'm also pretty confident that there's a version of Python that is supported, but we'll find out. So we're also, and this is something that's important to note, and I'm pretty confident that Harry yesterday in the tutorial series did a C# demo, and it was most likely using VS Code as the IDE to give a little variability there for the audience. I'm going to use PyCharm instead. It's not a lot of the same features are exposed for what we're going to be doing. Since we're not going to use the toolkit, we're just going to use the Neoexpress component. But I think it's kind of good if maybe there's a developer that uses one or the other, they can reference both of them to fit their development environment. A lot of the experience will probably be somewhat similar between the two. So to get started, there are a couple dependencies that we need to highlight. The first is BOA, and we're just going to open up a browser and see what shows up on there in a recorded meeting. BOA is our Neo Pythonic contract development environment. So you'll find it right here. If you do a quick Google for Neo3 BOA. And this will really walk you through a lot of the explanation for getting it set up, and how to run it, how to compile your smart contract, how to get started. I'll note we also have a pretty rich set of examples that are built into the project. So if you go in here to our tests, and this is actually another important thing to go over, we have a full unit testing framework that's built into the compiler. It's been there for about 2 years, and it's pretty robust. We actually self-test the project with it. And you'll actually find in here we have some complete smart contract examples in this BOA3 test directory. We also have a pretty extensive list of examples of the features that are in BOA. So for example, if we're talking about lists, in BOA, we support lists or in analog to lists. In the Neo environment, you can see we have a really nice example of how to use indexing on lists, right? And actually, there's also a built-in method that supports that as well in BOA. So I highly recommend people check that out. That's the first dependency for this tutorial or workshop. The next one, and we're going to install that through pip. It is a published package, so it's really easy to get access to. You just pip install Neo3 BOA, and I'll show you that in the workshop. The next thing is going to be Neoexpress. Right. And I'm, depending on your level of familiarity with the ecosystem, this is also going to be something that you're very exposed to. I would highly recommend checking this project out if you're doing any local development. In this case, we're actually going to use a downrev version because that's what I believe is installed on this system. The commands that we're running with are not going to be critical. They're not going to matter that much, but I will show you, I'll point out a cool feature of the latest release that is really helpful for developers who plan to deploy to testnet or mainnet. Okay, so today we're going to write a smart contract right out of my head, and we'll see if it works. So the first thing, right, obviously we want to set up the project, and we'll just call this, I don't know, Neo is cool. Since I like really confusing handles to type, does somebody want to, maybe we go with 3 O's just so it's something we know. And we'll use Python 3 for this project. Okay, so we have a pretty vanilla environment being set up, and we can all go get some coffee while PyCharm does its thing here. Okay, and it actually spits out a virtual environment for us. We're actually just going to delete that and start from scratch, since depending on which IDE you're using, may not do that. I'm also not very familiar with Mac OS, so we can use this one. It's cool, this virtual environment. The first thing that you're really going to want to do when you get started is create your virtual environment anyways. And you're going to do that by running, in my case, I'm aliasing Python instead of Python 3. So -m v and v v and v. And that's going to create your virtual environment. We already have one that PyCharm set up for us. So we'll just use that. And then you're going to activate it in our environment. You run the command. So, and this is going to be in a POSIX environment, right? So Linux or Mac OS, you're going to run source v bin activate. This is pretty standard Python environment, and I was already in the virtual environment. If you were in Windows, in a Windows environment, you're going to run a different command. So you're going to run this command, and it will activate your virtual environment. Okay. And then we're going to install BOA, and we're done. So BOA, when you install BOA into your environment, what it's going to give you is this command line interface. which is really pretty simple. What you're effectively going to do is point it to your smart contract, and it will compile it. And I'm just going to go in here while we're talking about Bo, and I'm going to create a directory called contracts. Okay, and then I'm going to create a new file, and we're going to call it the best contract. I guess we're in Python, so the best contract. There. Okay. Now this isn't really going to compile or transpile into NVM bytecode yet. There's nothing there. One thing to note here, and I'm trying to sprinkle in some general information with BOA. Whatever you name this file here, this entry point, that's going to be the name of the contract that's written into the metadata or the manifest for the smart contract that's going to be deployed. Okay, so we have our contract file. The next thing we want to do, and this workshop goes through the entire setup. So if you already have Neoexpress configured, you can maybe fast forward if you're watching a recording. If you're watching live, you get to bear with me for a couple minutes here. We also need to create a private node instance or network instance, and you'll see when I ran that, and let me highlight it a little bit here. I wish I had presenter tools. I would click and make this fancy or highlight it. But what I'm going to run here, or ran, is just neoxp create, and it's a command to basically initialize a private net. It creates this file called default.neoexpress, and you'll see all of the configuration data required, or most of the configuration data required for running a private network, including the Genesis account, which holds all of our Neo and our gas. It also has this magic number, which is pretty important for interfacing. This is really critical for us, and we'll talk about that a little bit in a follow-up workshop. But the RPC port is pretty critical when you start talking about contract interfacing for like front end, for example. Right, or actually for really any interfacing. Okay, and then we're also going to create, I'm just going to create a new wallet here. And we're going to call it the COZ wallet. Okay, so I think we're ready to run our private net. And I'm going to do that. We're going to go into like a split terminal mode here in a second. So then let's run this guy, and we're gonna do, I know we can go faster. So this neoxp run command will start up your private net, and the -s will allow you to set the block time target. 1 is kind of the default that I use, so it's a 1 second block time, which is really helpful for development. For the sake of this tutorial or this workshop, we're going to do a 5 second block time because I think it lets us see the transactions a little better in the workshop. It kind of illustrates the concept a little better. If it's 1 second, by the time you see the transaction, it's already gone. So we'll run it, and you'll see consensus is started on our single node consensus node private net. And we're spitting out blocks. So you'll see blocks are relaying and they're persisting, and you can see the transactions. All of them are empty. And we're going to throw this over here. Okay. So now what I'm going to do is I'm going to transfer some gas to that COZ account. How much do we want? Let's just take a bunch of gas. So we're going to transfer what is that? How many zeros? A million gas from the Genesis account to our COZ wallet. Okay, and you'll see there's our transaction. So it's already been published to a block. So you can see TX equals 1. Okay, now let's get back to contract development. So all of this is kind of secondary to what this workshop is about, and that's the smart contract. So we have this the best contract.py here, and maybe I look, Robert, are there any questions so far? I'm not sure if there's a Q&A portion of this or not. Like a panel for that. Okay, well, I'll just continue and maybe there will be we can do a Q&A at the end. Okay, so
There will be a Q&A at the end of the session.
Great. All right, so to start off with a smart contract, the first thing we need to do, since we've already installed Neo3 BOA, is our imports. So BOA 3 is actually the name of the package. And we're going to export public, and then we're going to import interop storage. I'm notoriously horrible with typos, so we'll find out if any of those show up here. Okay, so what we're importing are a few methods and it's a decorator. So it's this public decorator. And what we're going to do, and I'm going to explain what this does in a second, but what the decorator does is it exposes, it tells the compiler to expose this method for public use on the chain, right? So it's kind of the difference between, I mean, in most languages, right? So you would have a public or a private method. So that's really what that decorator is for. If you didn't have this on our method, it would not be an invocable method. It would only be for internal use in the contract, right? And we're just going to do an init method, and we're going to say it returns a bool. And you'll notice that we're also, although in this example, it's probably not going to show up a lot, BOA is what we would call a Pythonic language. It's not like a perfect match to Python, right? Like it's not a one-to-one thing. There are certain features of Python which don't work or aren't supported. There are also other features we have which aren't native to Python. We try to build something out that works really well for Python developers and is very instinctive to use and natural to use. I think it's important for people to be aware that it is not, exactly Python. There are some slight syntax and feature differences. You can't do I can't do import numpy as np, for example, and then expect to use this numpy package in my smart contract. We're working on some of that type of functionality, but that's a pretty big goal. Okay, so let's do this initialization, and what we're going to do here, I'm trying to decide how crazy we want to get. We're going to kind of go back to the standard tutorial mode, and we're going to say put hello Neo into storage. Okay, so this is the first of those two methods that we've imported from storage interops, and the put is really what you're using to put content into persistent storage, right? On chain. Then we're going to define another public method here, and we're going to do get result get storage. We'll call it that. Okay. And we're going to say it returns a string. Now, I think it's important for everybody to also be aware here. So storage is using a byte array. That's the general storage data format. So when we get the data back, so I'm going to do that here. We're going to say that is byte. Sorry, I've been in a different language all day or this morning, so my syntax is a little off. We'll just do this and we'll let it handle it. Hello. Right, so this is going to be a byte array. We're going to need to convert it on our return. So if we do res, sorry. I believe that's the method. Yeah. And you'll have to bear with there's a defect in this version that is not recognizing some of these methods. And I have an alternative way to handle this if my syntax is still really bad. Okay, so now we want to compile, and the compiler will tell us, it'll fix all of my issues here. So we're going to do contracts, the best contract.py, input files not oh. There's one of my typos. Okay, and you'll notice here it does not like some of our features, and this is what are our libraries. And this is where I'm going to decide if we're going to move to a different approach for this or not. Importing. Oh, here's another one of my typos. Get rid of this. That's great. Okay. Importing, and it says I'm missing a return statement here. So you'll notice that I've, initialized the smart contract and I've said there's a return of a bool, and I don't have a return here. Generally, and you don't have to do this. Generally, for me, it's good practice to always include a return, even if it's a null or a nil value. I don't know, maybe that's a layover from old contract development experiences, but that's what I recommend to people. But that's also my preference for most languages and most environments. To always include even if it's a default return. Okay, so Neo3 BOA contracts, or it's really just the path to the contract, and it's compiled. And what you're going to get out is a couple things, and I'm going to refresh this. And you'll see now we have 3 files here. So there are 2 more that are in line with this best contract.py. We have this nef file and this manifest file. So the nef is your VM or your NVM bytecode, along with some other content. And you'll see if you open it up, you'll actually see some other stuff here. You're going to see the compiler version that was used. So in this case, we're using Neo3 BOA 11.2. And then you'll see the method. And of course, this isn't going to parse cleanly, but in this encoding, but you'll see, you can kind of get an idea that, yeah, our method is probably there. We have some hellos and some neos in that do parse out, and you'll see there's our data. The manifest is something I want to spend a little bit of time describing or going through. So this is really the metadata that is going to go on chain, that is used, it's used in a lot of different areas. It's very useful for developers. It's kind of a lookup of what the API is like for this smart contract. So you can see, here's that name that I mentioned earlier, the best contract ever, or the best contract. Even when I speak, I add typos apparently, or speechos, whatever we want to call them. You'll see that the name of the file automatically is placed here. You can rename the contract if you want. It's really just metadata. For the ABI, you'll see our two methods, init and get storage. In this call, we're not going to discuss events. Events are ways for smart contracts to announce that something happened. So, for example, when you do a token transfer, there's an event that is triggered where for people to listen to, like wallets, for example, to know that something actually transferred. We will also not be going through permissions, trusts, or really a lot of the manifest kind of metadata. We're going to save that for probably a future workshop, since this is really meant to focus on the basics. What I do want to talk about, though, is that public. So here, every method which is flagged as public, you can see is going to show up in manifest. So this is a really good way, especially if you have a really large contract, to audit it for interface security exposures, right? Maybe you accidentally have a method that's public that you don't want to be public. Instead of, if you have, I would say a smart contract project which has thousands and thousands of lines in it, and many, many methods, it's a lot easier sometimes to compile it and also audit here as a gut check just to make sure. So I'm going to show you right now, we have init and get storage. If I remove this line here, this public line, and then we recompile our contract, the manifest is going to update, and you'll see now we only have that init method. So removing that public decorator has that effect, right? So in this case, now you would not be able to externally invoke get storage. But okay, so here is our smart contract, and we're going to recompile it to make sure that we have that method. And then I think we can talk about deploying, if that works. If you want to see some of these, and maybe I'll jump through into that really quick. If you want to see what some of this actually looks like for like an actual smart contract that's in production, and this is like when the API for Dora is getting hammered. So, all right, so you can see there are a bunch of different projects here. And I'm going to go to this one because I think it's kind of interesting. So there's a band in the US that are releasing their pretty kind of a cool project. So you can see they've just deployed this. And this is really coming from the manifest, right? So you can see the name. This is a NEP11, which means it's an NFT. You have your block, time, return type, index. Here's the author, right? And you can see here what compiler it is. So in this case, it's C#, and then a contact. And then this is that nef file. So this is the script that goes along with the code or the project, or the smart contract. And then here you can see all of the public methods that are added. So once you start getting out to this many methods, it's kind of good to audit the manifest, certainly before deploying to like mainnet, for example. Right, and then here's some events. So in this case, as I mentioned before, when you have a token, there's a transfer event. So here's that transfer event. And we'll cover events in a future workshop. Okay, so we have our contract, we have Neoexpress running. Let's deploy it. So we're going to run a Neoexpress command to deploy, contract deploy, and this time, instead of pointing to the Python file, we're going to point to the nef file, which is the script, right? That actually represents the smart contract. So we're going to say the best contract.nef. Oh, and I need an account because we need to pay. So this is also, I think, a good point to discuss that. On Neo N3, the deployment fee structure is very different if you're than Neo Legacy, if that's the space you're coming from. It used to cost effectively 500 gas to deploy contracts. At one point in time, that would have been like a $30,000 contract deployment experience. Or, very expensive. Now it's considerably cheaper. It is important to note that that's heavily dependent on the features that you have in the smart contract. Most contracts cost about 10 gas to deploy. So it's kind of a good ballpark, although, again, that's heavily dependent on features. Couldn't find. Oh, typo. All right. Okay, so we just deployed our contract, and we're going to go over here to look for the transaction. And you'll see we deployed it, and there is the transaction. And to gut check this, if you're not in a toolkit environment, you can do neo xp contract list, and it will list all of the smart contracts that are deployed to your private net. And we'll see here, so these are all the native contracts. You can see there's our Neo and Gas token and their script hashes. So if you're doing dynamic invokes or contract calls, so like contract to contract interfacing, this list is kind of helpful. We'll also talk about that a little bit in probably an upcoming workshop for the props. But here's your smart contract right here. And we can see the best contract, and this is the script hash. Okay. Now I suppose we should probably invoke the smart contract. Don't want to go through the work of configuring an entire Neonjs environment, and we're kind of focusing on smart contract development. But I would like to show you guys how that works a little bit. So let's see if we can do the contract invocation to, how do I want to do this? I'm going to cheat a little bit here, and I'm going to send some code. How do I want to do this? Sorry, I'm evaluating how I want to handle this. Let's do it this way first. So we will just follow kind of our standard approach here, and we're going to create an invoke file. And I think it's important to note here that there are a bunch of different ways to invoke smart contracts. And depending on what you need to do, some have, some are better than others, right? So in this case, for example, in this test environment, this is actually a decent way of executing some of these contract invocations. I generally, and again, this will be showing up in a later workshop, recommend that people probably look at building out an SDK and then using that to directly invoke their smart contracts, because it's portable to, testnet or mainnet, for example, and others can use it, right? So here we're going to reference this script hash, and we're going to use some of the native features of Neoexpress here. So we're going to do contract. So we're going to enter our script hash, and then we're going to stick the operation here. And I think I named it init. Find out from the manifest. And effectively what I'm going to be doing is I'm going to map this into this JSON file. And I'm guessing this is probably familiar to ecosystem members. Okay. And what this is effectively doing is it's a run file for Neoexpress that kind of tells it how to invoke a smart contract, right? Okay. So now we're going to run this file. So we're going to do neoxp contract invoke. And I should note, if you ever get stuck on this, Neoexpress has some really good command line helpers for method descriptions. And we're going to go to contracts, the best contract init JSON. Okay, and we're going to invoke that contract. And again, we get this error, right? Either account or results must be specified. So we need to pay with our COZ account because, and this is actually it's accurate for Neo Legacy, and I'm going to make references there because some people may be coming from that environment. There are really two fundamental types of contract invocations. There's in the ecosystem, we call it a test invoke, but it's really a contract invocation which does not trigger a state change. So there's no like storage manipulation, for example, or persistence. It's read only. There's certain methods which also require, which don't work as expected in this test invoke experience, and those types of invocations don't actually require a signer, right? When we talk about changing the state on the chain, so like manipulating the contract storage, there is a fee associated with that, and you need to sign the transaction. So in this case, we're going to use that COZ account that we created, or that key pair we created earlier. We're going to sign the transaction with our private key, and we're going to relay it. And we're also going to attach the transaction fee in gas. Now, the reason we need to run it in this way is because if we go back to our smart contract, we have this put, right? So we are actually manipulating the storage state or the scope storage for this smart contract by storing this hello key and neo value to it. And we'll see later, or we can go through discussing this now. This get storage method does not have that issue, right? There is no state change here. We're just reading data and running some minor compute. So this This method can actually be run for free without relaying a transaction to the network. It's a read-only operation. So we're going to invoke this method. And am I the best? There's another typo. So this is also probably pretty good. And we'll see over here now. There's our transaction. So I want to show you guys something else really quick. So if I take this script hash, neoxp contract show storage, and I didn't do this before, but I want to show you guys. I also could use another couple cups of coffee, which would help me here. So we're going to show the storage contract shows. Contract. Oh, sorry. This is actually also a really good example of live working on this. That's the command. You'll actually see here our contract, right? And this command will list out the storage in the smart contract. So we have a key and a value. Somebody can do this later. This key, this hex value translates into hello, and this will be Neo. So this is also a good way of debugging for some simple stuff. If you start talking about like class serialization and deserialization, usually you're going to want to look at some more advanced concepts for debugging. But this is a really good kind of sanity check, right? Okay, so we have our contract invoked, and we have something persisted to storage now. Maybe we should get some data back or see if we can do that. Now, there are a couple ways to do that. The first one is actually to do the exact same thing we did before, where we have this the best contract in it JSON. We could create another one which invokes get storage and returns the result. We could also invoke the smart contract using Neonjs, which is kind of more representative, I think, of maybe a production environment once you have your setup configured. I think there are a lot of ways to do that. NeoBoa also has some built-in functionality where you could, as I mentioned before, write a unit test that invokes the contract and pulls the data and checks it. Today, I am feeling like we have a couple minutes left. Maybe we really quickly, and I'm going to send myself some code for us to walk through here. Let's see, how do we want to do that?
Tyler, we started a few minutes late, so if you want to take a few minutes more, I'm okay with that.
Sure. Yeah, I'm just I'm thinking about how to do this. So we'll just write it really quick. That's easier, probably. Okay, so we're gonna just create this new directory, and I'm gonna call it HTML. And this is, it's actually probably easier for me to write an actual package that does this, but not particularly familiar with this computer. Okay, so I'm just going to import this ID is weird. Okay. All right. And this is like probably the most basic example possible. Neonjs is also available on NPM. It's registered. That's how most people use it. I think for the sake of this tutorial, this might be a little easier to explain concepts, though, since we don't have to go through all the NPM or the yarn configuration. We don't have to set up like a React app, that kind of thing. So this is kind of bare bones. I believe we're going to do a props workshop. We can go through some more advanced examples where we're doing like class serialization and deserialization and smart contracts, and like class instancing, and we're doing a lot more interfacing with Neonjs, like loading like kilobytes of data on J and pulling large data sets off and things like that. But for the sake of this kind of basic tutorial, we're going to just interface this way. So remember that that Neoexpress configuration here. So we have this RTC port. It's 50,012. So we're going to use that here, right? So here's the port, and we are running on localhost. And we're just going to create this function. And I am referencing something here. So if people are kind of laughing at me as I do this, we're wondering how, then that's where it's coming from. So we're going to write a script really quick that, one second. We're just going to do, you know what? I'm just going to post this. I think that's easiest. I'm going to post it into the devlog channel. For people to reference. That's probably the easiest approach. And then we'll come over here. Fabian's online, huh? And Gil. All right, so we're just going to do it this way because it's a lot easier in this case. So we're going to come over here and look at that fast forwarding. And it went to the wrong place. There we go. Okay, so here's our code, and we are missing a tag at the top, as well as the import. So where did I stick that? There we go. Okay. And we're going to verify. So this code was copy and pasted from another workshop or tutorial, and we're going to notice this script hash is probably going to be different here, right? Because that contract was slightly different. Okay, so this code is a really lightweight Neonjs example. And what it's going to do, and this is really the meat, this hello new blockchain. And I'll open this up really quick. Okay, so there's a button here and it just says hello. And what it's going to do is it's going to invoke in this case, it's the hello method, which we don't have anymore. We have this one. It's going to invoke this smart contract at this script hash, which is the one that is associated with that smart contract that we saw down here. Right there. It's going to invoke that smart contract, and it's going to invoke the method getStorage, which is public, and it accepts no inputs. Okay. You'll see we're creating this network facade. using Neonjs. And then we're going to invoke that method. Now you'll notice when we do this invocation, we aren't actually populating. There's no need for a wallet, right? And as I mentioned before, in this specific case, we're not actually changing the state with this method. So we don't have to sign. So it's free, with exception of the compute cost of the node, this local host that has to be used. And then something to be aware of here is that all responses, and maybe it's easier for me to just show you. Where are we? Okay. I want to show you a couple things here before we jump to Q&A. So I'm going to press this button and it's going to invoke. Can I read properties of undefined reading network? Sweet. Right at the end. Did I not add network? All right. Since this is contract development, I'm not going to, and we're kind of at the end, I won't go into this, but maybe in the next workshop, we can dive into Neonjs. The important thing to understand is that the return type for the stack on Neo and 3 is base64 encoded. So if you do start doing contract invocations and that your response isn't really what you're expecting, I would definitely recommend looking at that. The other thing that's very important here, and we'll cover this in a little more detail next time since we're kind of the top of the hour, is this magic number, which is a critical component to signing transactions. It's kind of it has a number of value propositions. One of the big ones is that it's a good security measure to prevent people from pushing contract invocations to the wrong network, right? Each network, so testnet, mainnet, even your private net, they all have a different magic number. So it allows you to handle that. So I think we'll probably call it here. This is a relatively good stopping point. It might be reasonable for us to do a follow-up workshop where we actually focus more on Neonjs and the actual interfacing part. Then we could go into a lot more details there. But we'll also cover that in some of the props project stuff as well if we do a workshop for that. So thanks.
Thank you very much, Tyler, for that informative presentation. While we're waiting for people to enter their questions, because we have officially entered the question and answer part of the session, why don't you tell people a little bit about props? And people, for those of you out there right now listening to the broadcast, this is the time to put your questions into the text devlog channel, and we will pass them on to Tyler.
Yeah, so props is kind of a scaffold project for a much larger initiative that we started working on, which is kind of building out higher level functionality. So you'd probably kind of refer to it as layer 2 functionality in the Neo ecosystem. And one of the, while not critical, one of the things that's interesting about it is that they're all the contracts are open, or at least that's kind of the idea for most of the features. So there's a really strong API definition in TypeScript. The contracts are well documented. Really, this entire tutorial is everything we've gone through in this workshop is pretty much automated. We also package some scripts which are useful for developers, like there's like a node script, for example, that will deploy smart contracts to any network, whether it's private net, testnet, or mainnet. We include kind of a reference for system level testing. We also include, what else was I going to say? Oh, we include like another good example would be a script that handles contract update, right? And all of these don't require a full node, so you don't have to like download you don't really have to run like Neo CLI for doing contract deployment, which we were seeing a lot. And Neo N3 is a relatively new blockchain platform right now. We were seeing that a lot in the beginning with Neo Legacy, and we kind of saw it a little bit recently as well, where people are people are using Neo CLI. They're doing like a full chain sync, and then they're deploying smart contracts. They're, while not probably well documented, you can do contract deployment and update using Neonjs, for example, which allows you to do it without syncing a node or doing anything like that. You can do it remotely over RPC, which makes things a lot easier. So I'd really recommend people check out that project. We're also building out, and I see Gil's on the call, we're working on building out some really easy to use contract interfaces for every smart contract development language in the ecosystem. So all developers will have access to these tools and be able to use them. And I would also recommend, since I get to talk freely right now, I would recommend that people also check out the Grant Shares project, which is running right now or was just launched. I think this is a really good forum for getting funding for ecosystem initiatives. I know there are pretty much everybody who's on the call right now is probably a developer. So I would highly recommend checking that out, in addition to the Polaris Hackathon, which you guys are probably participating in right now as well. So that's my plug. Thanks, Robert, for posting those links.
My pleasure. And we have a question from someone named Gil. You may be aware of him. He would like to know why you prefer JetBrains IDE for smart contract development over Visual Studio Code with the tools Neo provides.
Well, it's written in Java is the answer that Gil probably wants to hear. The actual reason is more of a historical reason. So I just had a conversation with Harry about this as well. I kind of got pulled into their ecosystem with WebStorm, probably 10 years ago, not 10 years ago, 5 to 10 years ago, I got pulled into their ecosystem using WebStorm, and then I kind of bought into the suite. So you can see when I was presenting, I have like PyCharm installed, I have Golang installed. So I'm just very familiar with the interface, and it's what I prefer to use. I also know all the I'm familiar with all the command line experience for all the utilities I use. So that's my primary reason. There isn't really a feature justification for it. I don't use like UTrack, for example. I don't use a lot of their extra stuff. But that's kind of why. It's just historical reasons. I will acknowledge, and I've talked to Harry about this numerous times, I will acknowledge that the features for the debugger toolkit with VS Code are very good. My development environment isn't, it would be a bit of a shift for me time-wise. I also, and this is kind of an ecosystem excuse, but I think it's important because people do come into our ecosystem from a lot of different, with a lot of different development environments configured. So it's a good reference point if I can say, well, pretty much everybody in the ecosystem is going to use VS Code for workshops. This provides a little different context where maybe some developers are coming in and they are using the JetBrains suite. So it's kind of good to show what that experience looks like as well. But that's really just my excuse for not switching over.
Yeah, great. Thank you. We have a question from Edge. He says he really likes using the Neon.js facade and experimental package, and he wants to know if there are any plans to add similar utilities to Mamba.
Yes, actually. And I would recommend, and I'll just actually, I can tag the development lead on that project to take a look at your message. There are, and I believe we've actually prototyped that out. So there is an RPC. We've been calling it Mamba Lite, where it's effectively a Node SDK for Python, similar to like Neonjs, for example.
Nice.
Yeah. So there is, and we've explored it. It's primarily a resourcing issue, but yeah.
Okay, Polygon has been working on a question for quite
So he's mentioning video game development. Um, the video game development environment is really varied. I would personally recommend going. I guess I should step back. If you are trying to pick a language to write contracts in, I would probably go with whatever is similar if there is an analog in our environment for whatever language you have experience with from video game development. Um, Generally, and Gil's going to say Java, Java, Java. If you are a video game developer, if you're doing like mobile game development, right? Neo3j would probably be my recommendation, just because you're probably familiar with Java. If you are experienced with working with like Unreal Engine or Unity, for example, I would probably say look at like the C# experience, just because although the Java and Go environment are also going to be familiar to you. Yeah,
okay.
and the
Now
reason I say that, yeah, so the reason I recommend that is because a lot of development in the Unreal environment is done in C++, if I remember correctly. So you may want to pick a language that you're more familiar with there. If you're doing more of like the infrastructure backend work from a game development perspective, or you're doing, I guess I would probably recommend Python then, right? So, or Boa. So it kind of depends on where your experience is language wise. Ultimately, I'm trying to think of the best way to put this. The For people coming into the blockchain world, writing smart contracts and like just starting out, I think it's important to understand that you really don't want you want to minimize the amount of stuff you're doing on chain as much as possible. Like if something doesn't have to be on chain, don't put it on chain. There should really be a reason for doing that, because it's a lot more expensive to do, both from an integration and like sustaining perspective, and from an actual financial cost perspective, right? Because you pay for that, and for that deployment, you also an update. You also pay for every invocation or every transaction you make. So this is a really important kind of system level concept. So from a game development perspective, when you write a smart contract, really you only want to put the bare minimum on chain, and if you can, or if you can get away with it, you want everything else to be off chain. So all of your experience with game development really applies here. You can still develop your game off chain. Really, what you're looking for is the part that provides that decentralized component. So where do you want? And there are a number of different value propositions for that. But you really want to consider, like, in my game, which pieces do I want to decentralize and why? And then try to condense that down and have a smart contract that focuses really on those core features. You don't want to put like the entire compute engine for Unreal, as an example, on chain. Like, it just isn't. It's not feasible. And blockchain's really a tool. So, and it's not a tool that's designed for that. We have a lot of really good custom-made tools for that. So, I recommend any new developers in blockchain really consider what they can get away with not putting on in the smart contract. It will save them a lot of time and headaches later on.
Polygon did add that he wants to incorporate NFTs into the video game, and would that affect your choice of a language at all?
I would be I'm going to be relatively biased and chill looking at the props project, which has BOA contracts right now, because there is an NFT in a development environment already configured. So he could get started, immediately. But really I think, and Gil's muted here, but I'm pretty sure that pretty much every language right now has a like a NEP 11, which is the NFT standard in Neo, a NEP 11 template or smart contract example. So if you're looking at building an NFT, you're not going to go wrong with any of the languages. For me, I'm gonna pitch and say use BOA and use props because that's our project. But I also do think, generally speaking, props has a bit more of a kind of a metaverse or a game development leaning. It has some higher level tools which would make that helpful. But
Excellent. Do you intend to have a props workshop in the near future?
yeah, I think so. I think that would be fun. But yeah, you're not going to go wrong. Really, the community has spent a long time building up our the capabilities of all of these compilers. So you're really not going to go wrong with anyone you pick, whether it's C#, Python, Java, or Go. They're all really good. They're all pretty mature.
Excellent. So, and hopefully we'll see a COBOL implementation soon. Okay. People, this is your chance to ask questions. I'm one of the leading devs in the Neo ecosystem, so please get them in now. Otherwise, we're going to wrap things up very soon. Edge is typing. Type faster. No, we got some questions coming in. So, by the way, Tyler, props. So even though they're written in Python, they can be used or accessed by any language, right?
Yeah. So
I'm talking about the deployed smart contracts.
Yeah. So this is actually a really important concept in Neo, right? So because Neo, so we have this NVM bytecode, right? So all of our smart contracts are compiled into that. You feasibly could have a Java smart contract and a Python smart contract that have the same exact bytecode, right? When they're compiled into NVM bytecode and they're deployed, they byte for byte are the same. Now, in theory, so it really doesn't matter, and this kind of goes back to Polygon's discussion. It really doesn't matter very much which language you pick, as long as the features you need in that compiler are supported. So with props, for example, the source code or the contract source is in BOA, right? So it's Python based. But once it's deployed, like the Neo blockchain doesn't know the difference between whether it was written in Python or JavaScript or Go or C#. It just knows the NVM bytecode, right? So you can write a contract in any programming language to interface with any smart contract that's deployed on the Neo blockchain, irrelevant of which language the source code is in. So Gil, for example, has written some of the, and his team have written like the grant shares smart contracts, right? Those are written in using, I'm assuming, Neo3j, so they're Java based, but they're deployed on mainnet in NVM bytecode. So I could write a BOA based Python smart contract and interface with his smart contracts, even though the source code is in different languages. It doesn't really matter. And I think this is a really important concept in the ecosystem. So while we support multiple languages, at the end of the day, what we're really writing is NVM bytecode, right? That's like, at the end of the day, that's where it all ends up anyways. So the different language distinctions are really they're user experience tools for developers, right? It's similar, like you could write a bunch of ones and zeros for your code, and at the end of the day, like if your ones and zeros are right, then they can talk to other ones and zeros, right? It's kind of the same concept there. The programming language is really just an abstraction of the underlying bytecode that's being executed. So.
Excellent. Okay, so Ixie is typing something. I think we need to wrap this up really soon, though. I don't see any other formal questions, and Ixie is on the COZ team, if I'm correct.
Yeah, he's probably answering Edge's question about Mamba.
Got it.
Guess.
All right,
Yeah,
so is there anything? Oh, I'm sorry. Go ahead, Tyler.
Oh, I was just going to say IHJE is he's been in the ecosystem for about 5 years. So he's a very good resource, especially for Python.
Excellent. Ishier. Okay, so I totally stepped all over your user handle, Ishier. I'm sorry. I will remember this. Okay, so I think we're about done here. I want to thank everyone for attending today's technical workshop. We really appreciate your time. For those of you in the Polaris Hackathon, good luck with your entry. My name is Robert Oshner. See you next time, and everybody, please say goodbye.
See ya.